Simplifying surds, example 1, 5 root 3 plus 2 root 3 minus root 3. Well, the first thing that causes people a bit of a problem is, what do we do with this term here? Well, that in fact is 1 root 3, but the 1 is not usually written. Now the fact that we have a root 3 here, and a root 3 here, and a root 3 here means that we can simplify. Imagine we had the expression 5x plus 2x minus 1x. Without any hesitation, you would say that was 7x, take away 1x, that gives us 6x. Well, the same thing happens with these surds. We've got 5 of one thing, plus 2, 5 plus 2 gives us 7, 7 take away 1 gives us 6. So the answer then is 6 root 3. Now what happens if we have different surds? So we've got a root 2 here and a root 2 here, so those two will simplify. We've got a root 7 here and a root 7 here, so these two will simplify. Gathering together like terms, what we can do is circle the like terms. We may not want to do this. This is the sort of thing you did in second year. If you are going to circle like terms, make sure you include the sign for the term, that's important. Then what we can do is circle the two root 7 terms in a different colour. So 6 root 2 plus 8 root 2. 6 plus 8 gives us 14, so it's 14 root 2. We've got minus 3 root 7 and 10 root 7. Now we can change the order. We can have 10 root 7, take away 3 root 7, and that gives us 7 root 7. Now there's another simplification that we do with surds which is interesting. We start off with one surd and have to simplify it as far as possible. What we want to do is to find the biggest square number factor of 48. Now remember the square numbers, not 2, 1, 4, 9, 16, 25. So 1 squared gives us 1, 2 squared gives us 2, 3 squared gives us 3, 4 squared gives us 4, 5 squared gives us 5, and so on. So 36. 7 squared is 49, and so on. So what's the biggest number from this column which divides into 48? That's what we want to find. And the biggest square number factor of 48 is in fact 16. So what we can do is we can write root 48 as root 16 times something. Many times does 16 go into 48? 16 divides into 48 3 times, so it's going to be square root of 16 times 3. Then we'll break the root up and have root 16 times root 3, each number under its own square root, and square root of 16. Square root of 16 is 4. So the simplified form of root 48 is 4 root 3. Second example of this sort, what about root of 150? Now, so let's go down this list of numbers. We can forget about the 1 doesn't help us at all. Which of these numbers divides into 150? What we can maybe do is extend this list. So 49, that was 7 squared, 8 squared 64, 9 squared is 81, then 100. So what's the biggest one of these numbers that divides into 150? I think it's this number here, 25. How many times does 25 divide into 150? It's 6 times. So what we can do then is write root 150 as the square root of 25 times 6 and then split it up into root 25 times root 6, and the square root of 25 is 5. Root 6 is the simplified version. Remember the square numbers? Here they are here. What's the biggest number from this list that divides into 32? I think it's 4. Now, what we want to do is to apply our knowledge of Pythagoras to this right angled triangle to find the value of side A, and we want to express A in its simplest form. So, I hope you can see that we're calculating one of the shorter sides. We already have the hypotenuse. So if it's a shorter side calculation, we must have a negative. A squared equals 6 squared, take away 2 squared. 6 squared is 36, 2 squared is 4, and 36 take away 4 is 32. Now remember to square root at the end. So there we are. Now, the biggest square number factor. So how many times does 4 go into 32? It goes into 32 8 times, so I can write 32 as 4 times 8. And I can split it up. And the square root of 4 is 2, so it's 2 root 8. But there's a problem here. It's a mistake that I made deliberately, because some of you will make this mistake as well and not quite know what to do. The square root of 8 is not given in its simplest form. So how do we simplify root 8? Well, let me do that separately. So root 8, well, that in fact simplifies to root 4 times root 2, which is 2 root 2. So this answer then is 2 times 2 root 2, and that equals 4 root 2. Now this extra working is required if you don't get the biggest square number factor. So what I'm going to do is I'm going to do this calculation again. The biggest square number factor of 32 is in fact 16, so root 16 times root 2, square root of 16 is 4, so the answer is 4 root 2. And that's the same answer we got by a slightly longer root. Last few examples. Consider these two surds. What we want to do is so those are given separately, and there are instances when the easiest thing to do is to recombine the two. So if we have them under the 1 square root, 2 times 8, 2 times 8 is 16, and we know that 16 is a square number, so the square root of 16 is 4. That's what we're going to do. Example 7, and the last example then is, here's a second example of this type. Now we have 3 square roots multiplying, 3 surds, and I think what we could do is just recombine into 1. So 3 times 4 times 6. 3 times 4 is 12. 12 times 6 is 72. Now, what we want, remember, is the biggest square number factor. 4, 9, 16, 25, 36. 36, in fact, divides into 72. So 36 and 2. And that gives us square root of 36 is 6. So the answer is 6 root 2.